So yeah, I'm very excited to be presenting here Construction Tech today. And we initially presented this session at Phius CORE in Houston last year. And what we want to focus on is, as the title says, in air sealing, in particular in panelized construction. So what we have all learned going through passive house training is drawing that red line, identifying where the air barrier goes. So that's a pretty broad stroke, and at first sight, mostly not that complicated. But what happens when you zoom in and a 2D drawing turns into 3D geometry, and offsite manufactured panels actually have to connect airtight to site-built load path. And with that, scope and responsibility between general contractor and panel installer must be pretty clear and communicated. And installation also has to be fast and efficient as well. So that's the process that we want to show today, and really focus on how do we collaborate as a team and work together and make a project like this airtight. And what we don't really want to focus on is the size, cost, and complexity of this home as a passive house. We as a team inherited this project, and initially there was no regards towards energy efficiency or choice of materials. So we accepted the challenge and saw it as an opportunity to further develop panelized passive house and air sealing strategies. And we will be able to use those on future projects that might not have budgets like this. So this was a really big opportunity for us, and we learned a lot, and we can share a lot going forward. So as Shannon already said, these are the presenters, and I think we can make sure we explain each of our roles. But first, Laura is going to explain how she took on this project and how she put the team together.
So hello, Laura. Everyone. It's really great to be here. So I am going to talk about the team and how I built the team and how I came to be engaged by Larry Weintraub, who is the architect working with Appel Architects. And they are a traditional relatively traditional residential, sort of architecture firm. They were not versed in, super energy efficiency or the kind of technical stuff. And as any good professional, Larry recognized when he talked with his client who wanted some of these things that he didn't have the expertise to do it. So having gone to one of our a BluPath presentation at an AIA conference on passive house, he also was on the zoning board for the Italian market passive house, which those two things, he called me up and said, I've got this client, and off we went. So we spoke with the client, and we did our initial values and goals conversation with him, which we have about 12 points about sustainability and aesthetics and budget, et cetera, that we talk deeply, learn from, and teach our clients about things. We hear from them, and we give them information that they might not have in order to, and then we have them rank these 12 items. And in spite of the fact that this is a very large 11,000 square foot house, which is not in its size very sustainable in terms of 2 adults living in it, but almost everything else was deeply sustainable. So every project has constraints and opportunities, and as Ilka said, that was one of them. So when we spoke with Bill, he talked about this energy recovery ventilator that he'd heard about from Zender. And he talked about that he thought it should be a very airtight building and it should be really well insulated. And basically I said, you're talking about a passive house. So he's a great researcher. He looked up and he said, indeed, let's do it. And we're going to go for certification. So off we went. We started to build this. Seemed like it was a very good candidate for the panelized system, and particularly because it had the deep sustainability objective of also being low carbon. We spoke with Ilka and Steve from Holzraum about, you know, the appropriateness of them thinking this was a good project for them. That seemed like a good idea. Together, we also brought on Chris Sarek from Sarek Mechanicals. Chris had worked on a project for us, and he'd also done Passive House. He does modeling that interfaces with the incredible sim model you're going to be seeing shortly that Holzraum produces. And so we brought him on board. The other thing was trying to find the contractor, the builder. Besides, Holzraum brought on New Energy Works, but we had to have a site builder. And we're in out in the country. So just finding someone in New Jersey, couldn't find anyone except a commercial firm that had taken the Passive House training, contractor training. And they really, they'd never built one. They'd only taken the training and they did commercial projects. So it didn't really feel like the right fit. I ended up searching, fine home builders in the area, and I came across Vanco. Having done this before, my BS detector is what I have honed pretty well. When someone is over enthusiastic, a contractor, I generally get my hackles up and I think, yeah, because I've heard this before, over enthusiastic. And then as soon as you get on the project, they're a bunch of whiners and complainers. But Vanco was very professional, and he basically said, we work with architects, we do complicated projects and regular projects, and if you design it, we'll build it. I don't care what it is, but I'll do it, and I'll do it well. So tell me what I need to do. And so that seemed reasonable. I did some research and vetting of him, and he seemed like a good candidate. I had good conversations with him. He understands basic building science, which is so important. And it turns out our client's brother-in-law, I think it was brother or brother-in-law, had worked with this contractor. So he sort of seemed like the right fit. And he turned out to be an excellent fit. He ended up taking the training, and we proceeded. One of the things I told him and gave him some information and some videos was that airtightness was going to be part of his contract, right? It wasn't something that he could choose to do or not, or do not well, or not do well, excuse me, my English, but that it was essential. And so what's important is that now we have a lot of players. So this is a big team, and there's a lot of cooks in the kitchen. So trying to figure out exactly who does what and where their obligations start and stop is one of the most important things we have to do. Like, what is site? What is factory? What is design, which is the aesthetics at this point of the project and the layout, and engineering, which was a PAL. And then what were the technical details? We ended up BluPath taking on a great part of them, Paul being the main designer of those. And, I, of course, did oversight and redlining in the not sense of the little red line, but redlining drawings. And so we proceeded. And the interaction and intense work that has to happen between the teams was intense and good. So I will, from there, say, take it away.
So we started out, Holzraum System then took basically the on the task of doing being co-CPHCs, and we did most of the energy modeling, and then also the panel design, which Steve is going to talk about. But we started out with, of course, with the energy model, and we learned that so the project consists of a barn or a workshop and a house, and initially both were we wanted both to be certified, but the barn, that was really hard to meet the targets with, just because of the volume, the surface, and very little interior square footage, really. But for the house, that was actually fully doable to meet those targets. And we basically determined the R values from there, and we could use our standard XP20 wall and roof panels. And from an air sealing perspective, what's great about those is that the air barrier is actually on the inside. So it's very, very accessible throughout the project. So just really quickly going through the assembly, and I know that Steve and Bryan are going to talk more about those, but basically from the inside out on the wall, we have a service cavity to protect the air barrier. The zip sheathing on the inside is the air barrier. It's a vapor retarder, and it's also the structural sheathing. Then we have a 2x8 wall, which is filled with hemp bats. And then on the outside, we really only have the cyclewood fiber insulation, and from there out a rain screen and the siding. So keeping that in mind, where the air barrier is on the assembly, we could start doing this big kind of broad red line stroke that we're also used to in 2D, which was fairly easy to just get around what is included in the envelope, what isn't. But here we actually had the opportunity, because we already had some of the 3D geometry available, that we could identify some tricky spots already and zoom into them a little bit closer. And basically look at them from our standard details perspective. But then that had to be taken a little bit further into the architectural details, which then Paul did. So Paul, if you want to take it from here.
Sure, thanks, Ilka. So this is a one page of many 2D AutoCAD details that we developed. The idea was to integrate the XP20 walls and roof panels, their ICF foundations, and then the floors, which were part of the Passive House envelope, were site-built. And the goal, of course, is to have that a constructible continuous air layer. So these details were included in the building permit set. Again, we were providing architectural consulting for the design architects, who are also the architects of record. And these were also submitted to Phius for their pre-certification. And looking for thermal bridges and so forth. These drawings were also used to coordinate who is doing construction, and to really talk about the discussion about sequencing between the trades, as well as defining the architectural details for the GC to build. This is a traditional design, and so there are traditional details such as clapboard siding, board and batten siding, trims, drips, and so forth. So we of course want to have those be seamless part of the design. And at the end of the project, we don't necessarily care what the inside is, as interesting it is to all of us, but we want to have the outside look like it belongs and has the design that everyone is expecting. So Steve Hessler and I had a number of Zoom meetings going back and forth between these 2D details and his 3D geometry model that we'll get to in just a second. We looked for complicated conditions and identified and saw those difficult air barrier situations. So they wouldn't be at the site scratching their heads on those cold, wintry, snowy days. We can go to the next slide, please. You can see on the right, we have a color-coded legend defining those other types of materials. The tapes and membranes, flashing, waterproofing. As you know, there's a whole laundry list of awesome materials that connect the membranes, that make that continuous air barrier possible. So these are close-ups of some of the details that we just saw, and they show the air and insulation continuity and really integrate those architectural details. The factory-built panels sit on a site-built floor. I'm looking at the detail on my left. And those sit on the ICF foundations. At the right is that legend and notes about the door and window rough openings. Mostly those notes are a reminder to me and to Larry, the design architect, as we were looking at the and coordinating the window dimensions and window installation details. I think that's all I need to say, and I'll probably hand it off to Steve to talk about the 3D model. So next.
Okay, so you know, we once Laura and Paul brought us in, and we were kind of working through who would do what, I guess, and sort of trying to define scope. It was a no-brainer for us to bring New Energy Works in for the project. We knew they would deliver an exquisite timber frame, and we also had been working with them to produce our XB20 wall and roof panels. So the first step, though, in really defining, you know, what's the most efficient scope designation and therefore pricing is to develop what we call an ROM model, or a rough order of magnitude model. This helps us determine the best scope designation between the factory and the builder, and that subsequently determines design scope designation between the architect, Holzraum, the factory in-house design team, timber engineer, engineer record, and the CPHC team. And so after many ROM model exchanges and meetings with the project team and the factory, we arrived at the New Energy scope shown here for first the workshop, which included a complete structural and visual interior and exterior timber frame, 3,200 square feet of XB20 wall panels, and 2,500 square feet of XB20 roof panels. Next. And then for the house, no timber frame, 8,000 square feet of XB20 wall panels, and 6,300 square feet of very complex XB20 roof panels. Next. These are just some basic kind of sort of standard approaches that we came up with initially for connecting the panels to the timber frame, and just some sort of basic construction connection details. Once we narrowed in on geometry and connections, we needed to narrow the focus on how to weave the air barrier around all of it. So this is sort of where we start, and then we can really get into how we're going to handle the air barrier in all these different. These are really just like a tiny few of the kind of corners that we needed to work through. Next. So a quick visual breakdown of the scope, a little closer. Foundation and load path. Lower load path members were by the builder Vanco. Next. The main and lofted floor frame deck and the airtight membrane between the steel members and the floor would be performed by the builder. Next. The timber frame was designed by Holzraum and fabricated and installed by New Energy Works. Next. Here are the XB20 workshop wall panels shown at production fidelity. Next. All the transition leaders between individual panels and between foundation to walls and walls to roof would be also provided and connected by the factory. Next. And the roof panels, of course, for the workshop. Next. On the house, another kind of little quick visual look at the scope. The foundation, including all the underslab insulation, the ICF foundation walls, and the Stego vapor and air barrier was performed by the builder. Next. We decided that the builder would provide all of the basement load path and the first floor framing and deck, which is pretty typical for a panel project. But we also decided the builder would provide all of the second floor deck and all the wood load path from the first floor deck all the way up to the roof. This is not typical, and it was a pretty risky move because in order for the panels to meet and provide a passive house air barrier, literally every single stick of load path that you're looking at needed to be exactly in place in X, Y, and Z by an 1/8 inch tolerance. We were nervous, and we only could have done this, I think, by really communicating this through the sim model and all the drawings and many meetings, but it worked. And I got to hand it to Vanco. They landed it, and it worked out really well. I also have to hand it to New Energy Works. This was by far the most complex XB20 roof system that we've ever done. And thanks to Vanco and New Energy Works, I'm now able to sleep again. So let's take a closer look at the control layers. So shown here, kind of all of them together, not including the roof zip sheathing, but basically all the controls are just sort of mashed them on here. We've got Mento as a WRB. We have zip sheathing panel as integrated air barrier on the wall panels and also the roof panels. We got rotoblast level band gaskets that are air barriers between XB20 wall panels. Then we have Intello leaders that transition between panels and stories. And finally, we have red Intello builder scope leaders. So I'll look a little closer at those. If I take the Mento off, you can sort of see a little better. You know, you basically have taped zip panels on the wall and roof panels inside of each panel, but then you need to transition. So we transitioned on the walls with level band, and we transitioned on the roof panels with tape joints between panels. We used Intel leaders between foundation to floor, floor to wall, and wall to roof. And so all those leaders are panel integrated, which means they're all designed and fabricated with the panel so that when they show up on site, we can minimize the on-site taping and detailing. The zip sheathing is a really hardy protective air barrier on the inside. There's building science as to why Ilka and I came up with this wall. But I got to tell you, when it comes down to the blower door test, having that like very protective and accessible air barrier is absolute gold. So it's weird, but we like it. However, next. Sorry, I'm like, you're ahead of me. I'm not doing
Yeah, I
very well.
wasn't sure. You have to.
Sorry, can you back up?
Okay.
My bad. There you go, right there. Sorry. So we really like having the zip sheathing as the air barrier inside, but it does create a lot of zigzagging necessary with some of the leaders. So again, that's where the modeling really can come in, especially with like things like this where you have cantilevers and offsets. You know, you have to really think them through. We don't always have to do it with a leader like this, but sometimes we just look to see what's going to be the best way to do it. Next. And then this just shows, this is like looking up at the roof. We didn't end up doing all those red racing stripes because we ended up doing, New Energy Works ended up doing some really long panels. But when you have roof panel splices over load path members like ridges and purlin, you need leaders all over the place. So like in a timber frame, typically you're going to see a ton of leaders above, you know, roof bearing members. Next. Paul, why don't you talk about this slide and then I'll jump back in for the next one. This is the regarding Chris Eric and the MEP coordination.
Sure, thanks, Steve. So this is, I need to move this out of my way. This is, you know, a complicated 3D drawing, and what you're looking at with the sort of teal and green things is the mechanical system, the ducts, the ERV, the mini splits, and this is at the second floor. And in the lower left there, that sort of inset detail is there to remind me to talk about the penetrations through both the walls and the roofs. And you can see that there are a couple of little green circles that are coming through the Mento. And those are the one of the ERV intake and exhaust. So we wanted to have a hole in the wall that we could locate, that we could build in the panel, but also that we could be sure that it is able to be air sealed, you know, airtight, and it is in the right location. You know, there's a fair number of rules about distances between exhaust and intake. We want it to look good architecturally because there's going to be people looking at this, not only the owner, the design architect. There was a kind of a homeowners association architecture review, and then there was someone else who was also throwing in design ideas seemingly from left field. We also, in addition to the ERVs, we had a sealed combustion fireplace, again, trying to figure out how do we go through that, through the thermal envelope and get the flues and the intake into there. And then we have a range hood with makeup air. So again, that's on the first floor, but those all are penetrations that are through these XB20 walls. They all, of course, need to be airtight. They need to be in the right location, and ultimately they need to look good. Next, please.
So our production models at Holzraum, our production models they're pretty detailed. They range usually between 5,000 and 20,000 parts. And so understanding and organizing them into assemblies and categories helps us to not only kind of navigate content really quickly during meetings and whatnot, but it also allows us to make sure that the transitions for things like air barrier perspective are going to make sure nothing gets left out, and also helps us to sort of assign who's doing what. So let's take a look, next slide, at like what that looks like in maybe a zone. So this is a zone where a dormer interfaces with the main roof. We go next. We're able to, because we have such a sort of dense part population, and it's all very accurate because it has to be for production. So that's the benefit of production design modeling. Well, since we have those things, we can just take, we call this a nugget. We can take a chunk out of the building at any time, whenever we want, and like work through this as a team to figure out. So in this case, we're like talking about, okay, what does the roof panel need to have on it leader-wise to engage the cheek walls for the dormer, and then at the roof, and then we've got load path, and then at the end of the day, we've got a timber frame T and G system. So we actually ran the roof membrane right above the T and G. It's kind of a weird detail because we were like, okay, where's the roof membrane going to go? So these are the kind of weird things that happen anyway. And then you put a timber frame in it and it definitely gets even more fun. So next slide. Once we like it in the model, we then still have to communicate it to make it happen in fabrication and installation. So the good thing is the model's great at generating details and shop drawings and communication drawings. Next. On the house, let's take another quick look at like kind of what our overall strategy was from the foundation up. So, you know, Vanco hooked us up with a Stego, a typical Stego leader onto their ICF wall, taped. We're always ready if we need to. I think they actually did, right? Did they actually put a membrane up? So with an ICF foundation, you're never really sure if you're going to hit your airtightness. We've never actually been burned, but we're always a little nervous. So in this case, they just went ahead and did it and put a membrane on the inside of the ICF. Then there's a leader transition that is ready to accept the floor framing. And then next slide. And then, yeah, I guess next slide. That's right. Are we on the same? There we go. Sorry. And then we have leaders between wall panels. We have gaskets, sorry, between wall patterns, the rotoblast gasket. Next slide. Same here, just showing sort of wall panels coming in with gaskets that come on the panels. Next slide. You can go to the next one, actually. And then we did on this a gasket at the top of the walls underneath the roof panels. It was a little challenging, got beat up a bit, but you know, it worked for us. There's other strategies as well that Bryan might bring up. And then the last slide, you're just seeing the roof panel come in. And then the next slide, Paul, I'm going to just let you kind of talk for a minute about, you know, this is sort of just the shop. We need to do a geometry review drawings, right? We know what we like in the model. Now we have to like get sign off. So go ahead and talk about that for a second, and then I'll go to the next slide.
That's right. Sign offs. You know, there's a number, right? As you know, we know there's a number of people involved in this, but ultimately, the owner and the architect need to sign off that this is meeting the architectural design intention. We're responsible for the performance. As Laura mentioned, you know, Larry didn't really know very much about Passive House performance, but he did know what he wanted the building to look like. And he knew what the owner wanted the building to look like. So that there wasn't a shop drawing process, which is similar to the sort of standard process. But we were looking at Steve's model in 3D. We could identify if there's any particular areas that we want to look at. You know, let's zoom on into that complicated corner where the transom sits on top of the roof. You know, as an example, and ultimately the contractor had to sign off and say, yes, I understand it. I can build it. I understand what my responsibilities are. This is what I need to provide so that when Bryan brings his crane and all of his panels, that they sit in the right place. Steve mentioned, at Vanco, and Kenny, they nailed it. It was, the panels came in, the details were resolved, the air barrier was continuous. And I'm not going to say that, there weren't any issues. I mean, I didn't hear about any issues. So they just figured it out in the field if there were. But it all worked out. But it also saying that the geometry review drawings, there was a lot of pages. There was, I don't know, was there 20 or 30 pages? And the windows had to fit, right? Because those were ordered at a different time scale than the panels. So there was a little bit of pressure to understand and to make sure that as we were reviewing it, we got it right. But I'm going to say, unless someone else contradicts me, that we did get it right. It is built, and so that's always a good sign. Okay,
next slide. So I'm just gonna. The only thing I just want to sort of say about these, the roof panels, is that this was new for Holzraum. What was new for Holzraum and New Energy Works on this, we always do something new and stupid sometimes on a new project. And then on this one, we were like, yeah, we're just gonna integrate all the eave framing and also come up with a thermally broken, next slide, a thermally broken, like cantilevered outrigger system for the eaves. So we had rake and eave integrated in the panel, which was really cool and it worked really well. And the idea was that by having a couple LVL outriggers that kind of come out between roof panel seams, like 6 foot or up to 8 foot on center, you could turn all the framing in between them so that there's very few penetrations. And that was great. But that could have been a nightmare for us on air sealing if the air barrier was on the outside, like a lot of projects are. So again, I just wanted to say this is a great benefit of having a zip interior air barrier on the walls up to the roof, is that you can pretty much do whatever you need to structurally with cantilevers and not worry about it. It does not interfere with the air barrier. So I think that's it. And now I think we're on to Bryan.
So as the factory fabricating the panels as well as the installer on site, we began collaborating pretty early on. You can see here some screenshots, some images that we used basically right after we got involved to start coordinating what the geometry of the panels were going to look like, where we figured we were going to set the crane to start the raising. All of this information is required as early as possible in the interest of not having to sort of rework some of the details. Because the sequencing is really what ultimately is going to define the order of operations. As Steve's alluded to, we try to include as many of the combinations within the panels to interact with all of the surrounding scope as possible. And so in order to do that and be able to execute that on site as efficiently as possible, really the raising order needs to be understood. Next. And so after we've really defined what the panels are going to look like, the splits, all of that stuff, Steve spends some time actually populating parts and building out the model. He's modeling all of the parts and pieces. Any of the masses that have gaps between them, he's able to identify as part of the build out of this 3D production model, any of the spots that otherwise are less visible in the 2D environment, such that we can really troubleshoot and work through the approach to air sealing. It's going to not only satisfy us as the fabricator and installer, but also the CPHC and anyone else who has involvement in that. We try to standardize as many details as possible, but as I'm sure many of you know, every project's going to have some level of special details associated with it. Next. A couple more images. We as part of this process, there's concurring meetings that happen pretty frequently. But in the meantime, we spend a lot of time sending each other screenshots and markups as a way to try to let each other know preferences on approach or identify tricky spots. On the left-hand side there was some load path that was going to be existing on site, a big beam holding up a second floor. And we were just trying to coordinate on a removable panel. Right-hand side of the screen there, this is actually the demising wall between the main house and the garage. And so you can see there that, you know, when you have each of these panels, they're going to have some length of material pre-applied to them as a leader to be able to tie into interacting scopes. But with everything turned on there, it gets a little bit busy. And so we use this as a way to really make sure that we were going to be able to keep that pressure boundary continuous between the main house and the second floor of the garage that was going to be part of that main pressure boundary outside of the garage below. Next. And so once this model's been fully developed, we are able to, you know, Steve hands it off to us. We spend a fair amount of time really dissecting it and figuring out the sequencing and basically toggling the parts sequentially and making sure that in the digital world, it matches what we're expecting out on site. It allows us to really, you know, have that full buy-in from fabrication to installation. Next. And so as an example, this is panel MN4. And so I'm able to isolate the panel, spin around it, check out the corners, the top of the wall, the bottom of the wall, make sure that it really works with the, you know, the rest of the interacting elements. Next. Well, most importantly is going to be that, you know, checking it out from the interior, making sure that we can follow that air barrier down below the panel, above the panel, and along the sides, just to make sure that we have a plan and a way to execute this on site. Next. Once we've really gone through and identified scope to scope, making sure that all of that is going to work, we're able to isolate each panel, make sure each panel has all of the necessary parts and pieces associated with it, and really we can toggle all the layers. Next. We can pick the parts of the layers apart. There's ways to toggle specific material types if we want to try to identify all of the leaders, things of that nature. Next. Once the model's been fully developed and fine-tuned, we get a panel drawing for each and every panel. Each panel gets 5 individual drawings, one for each layer. And so this is what the crew in the shop uses to actually build the panels. They're not working directly out of the model. It is critical that all of the details are included on these shop drawings, because this is what the crew in the shop is using to build these panels. Specifically, you can see on the center of this image, the red line at the top and the bottom. Those are the leaders. That's the length of membrane that was the Tello that was pre-taped to the top of the zip at the bottom of the zip, in the interest of being able to tie it floor to floor upon installation. Next. Give you an idea of what things look like in shop. We have an optimizing saw, and so we are able to cut the packs in the sort of the center back of the frame there. We've got an overhead bridge where we're going to frame sheet, nail everything together. The center of the frame here is the butterfly tables. This effectively what it turns into is each of these stations is a layer of the wall. And so the set of drawings follow each panel through. You can see in the sort of the center, the middle butterfly table there, that's where we're applying the zip sheathing. You can see the Intello leader on the bottom of the panel there. Next. And so roof panels, you know, they're treated exactly the same way. There's drawings for each layer. Steve alluded to this was a tricky one. Not only the way we integrated the overhangs, but the load path that was integrated into these panels was not, you can see there's some notches. The structure went right through the edge of that panel. Next. And so this is what that panel looked like after it was fabricated. We put the lifting points, all of the necessary parts and pieces to not only satisfy all of the structural and high performance elements, but also installation. You can see we've got the sort of the kickers pre-applied there as part of our lifting attachment. Next. And so as Ilka had identified, the two different structures here had different complications. The barn, because it had the full timber frame, the house, based on just sheer size and complexity. You can see in these images here on the edge of that one panel, there's a gasket. Because it's got the full timber frame, we don't have access to those seams to be able to seal them from the interior. So they had to have those accommodations pre-applied so that when these panels got fastened together, airtightness was already achieved. Next. And so for the roof panel, on the barn, because it on top of the timber frame, it got a layer of TNG, tongue and groove. We actually put down a Intello X, which is a high performance membrane that basically just got tied into that interior zip panel through leaders on the top of the walls. And so again, depending on what the structure is and what the aesthetic details are is really going to depend on how we're going to approach that airtightness. Next. And so for the main house, you can see in the picture on the left, the Intello leaders are all pre-installed to the top of that, to the top of those walls. Builder then built the floor system. We were able to flip the leaders up and keep that air barrier continuous up onto the second floor. Right side of the screen there is a hip beam coming in, and there's a leader pre-applied to the top of that beam so that when those roof panels sit down on top of it, we can just tape it to the bottom side of the roof panels. Next. And as Steve mentioned, these were some big panels. They were up to 32 foot, were the two longest one, 8 foot wide by 32 feet long. The entire, that air barrier was pre-applied and pre-taped to the bottom of it. And the panel was fully pre-insulated. Next. And one more shot of some of the load path structure with the leaders on top. Next. And so even with trying to include as much of the interacting airtightness accommodation as possible, there's tends to be some level of air sealing that needs to happen on site. One of the beauties of having the zip sheathing to the interior as that primary air barrier is that you have full access to it. And so if as you're working through the blower door test, you're able to go through and really address anything that may need to be addressed without having to disassemble anything. Next. And so this is one of the finished shots. I love this shot. It just gives you, it looks so crisp. Gives you an idea of what that load path looked like, and really highlights that air barrier. I think Ilka wanted to say something about this one also.
Yeah. I can. Well, when I jump in, I just wanted to say that this is a beautiful room, right? Even though there's no finishes in there, it's an awesome room. This is the room that's above the garage. And so this floor here is the thermal envelope. It's a complicated room structurally, and some of that complication comes because, as I mentioned, like the architectural design was a traditional design, and they weren't thinking passive house. Sebastian Moreno Vaca, one of my favorite architects, has said a couple of times in presentations, you can make anything into a passive house. I think that's true if you have a team that's sophisticated enough and works together and can help identify the issues that need to be addressed in order to make a passive house. But anyway, so right, this is a great room. It is exciting to look at it when you think about the parts and what it takes to make this room be airtight is pretty amazing.
Yeah, and I just wanted to add real quickly that we did pass the blower door test after a little bit of investigating air leakage points. And what's important is once you have the blower door on site, just make sure that you already also have tools to find and fix air leakage. That's the best way to do it. And then just really quickly, of course, windows are part of the air sealing strategies. And what's important for us, again, so this is our standard detail. And what we needed to identify as well is whose scope is what. So there's some tapes and sealants that go on the builder and some are on the factory. So really important to identify that as well. And then lastly, somehow I can't click anymore here. We did make a little YouTube video with Reimagined Buildings on I think it was the day the panels got installed on the barn. So if you want to see a little bit more, go ahead and check that out as well. So that's it.
Fantastic presentation. I am so enamored with this team. Let's give them a round of applause. Feel free to show your love for this team. Amazing. I don't know how many screenshots you all took, but I took quite a few, and especially the one of the thermally broken eave details. Super impressive. Thank you. Sean, do you want to jump in and say a quick hi before we hand it off to Kim for sponsors? Oh, it looks like you just...
Oh my goodness, that was amazing. The details there are unbelievable. And I mean, you talk about an all-star team diving in the details. I showed the that photo there that we all loved to the Huber team here at the Building Science Symposium, and they loved it. So they our good team works with New Energy Works, and Huber was happy to smile. So thank you to team to keeping things going. But yeah, we're a little bit behind the schedule. Let's head over to Kim to talk about thanking sponsors.
I'm actually going to hand off to Zach for sponsors, and then we'll come right back to me for events, and then we'll jump right into the Q&A.
Great. Well, a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Also, thank you to our founding sponsors, 475 High Performance Building Supply, Ingui Architects, Glavel, Minutair, Partel, Rockwell North America, Stillcorp, and Zola Windows. And thank you to our champion sponsors, Bewizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, and Source 2050. And a shout out to our patron sponsors as well, Brennan, Euroline Windows, Holzraum System, Inotech Windows and Doors, Lamelux, Longboard, RDH Building Science, and Sanderson Sustainable Design. Thank you, sponsors.
And first up with our questions, we are going to invite Dennis McMahon. Or Mayone. Dennis, are you with us? Would you like to unmute?
Yeah, McMahon. It's a tricky one. Anyway. Yeah. Thank you for the opportunity. It's great presentation. Thanks for that. Yeah, my question is, right, we're building with cross-laminated timber in Australia, and we're doing ADUs, but we're stepping up from that to multifamily. So obviously, the intention of using CLT was to be able to get not necessarily certified, but certainly Passive House standards was the target, because of the ability of monolithic panels to to provide a great seal. We're building in Queensland now, which is sort of southern Queensland, which is semi-tropical, but we'd be doing buildings both in tropical zones as well as other zones where we have a fairly large variations in temperature. And just interested on the the air and vapor barriers. Whether we need to start looking at different systems, both internally and externally, for the different zones.
Did you guys get that as a question? Did that come across for you? He is really asking, did the climate drive the air and vapor barrier layout? That was the short version.
It was a short version. Thank you.
You're welcome.
Ilka, do you want to take that and talk about the assemblies?
Yeah, I can take that. So we definitely did some hygrothermal analysis before we even or while we were developing this assembly, and it works really well in a cooling dominated climate because we have our vapor retarder on the inside. So we're avoiding, we're trying to keep the moisture out of the wall. But because it's very vapor open, it can always dry out if there's any kind of moisture that does get into the wall. We have not built this particular wall in a, super southern climate, and we have not done hygrothermal analysis on that. But yes, definitely, you always have to think about the vapor drive once you layer your wall or roof.
Yep. Thank you.
Thanks, Dennis. Appreciate that question. Next up is John. John, would you like to unmute and ask your question?
Oh, my question was already answered. Thank you.
Oh, wonderful. Thank you, John. And next up then is Stephanie. Hi, Stephanie. If you are unable to unmute and ask your question, I can ask it for you. Stephanie said, I'm not familiar with the term leader as you're using it here, definition, and there was some definition in the chat, but can you guys describe how the leaders are left on in the factory or applied in the field? And this relates to one of the questions I asked about the contractor that you brought on. So you brought on this contractor. How familiar were they with the materials you were using? Because you're specifying a lot of high performance materials that can be uncommon. So how familiar were they with those? And did they perform adhesion tests? Did they understand how to leave leaders and how to make connections and sequence all the air barrier components?
So, many of these products were new to this team, but because they were a very professional team, they were quite willing to be trained, to, get training, look at videos, try things out to make sure they knew how they were supposed to do it, and work with the rest of the New Energy and Holzraum who had maybe more experience with this. And so they just really picked up the ball and were quite willing to learn. And, that is so essential when you're doing the first one. And of course, the first project with anyone, whether you're designing or building, has a learning curve. So really it's, what is your attitude about learning? Theirs was good.
Yeah, I can say that, we did spend a fair amount of time in the details to be sure that we on the design end made sure that the leaders were documented and they're there and communicating both in drawings and verbally with the contractor. Said, a couple times I said, is the leader in place? Right, they're going to be making, there's going to be something that's going to be coming on site. Are you ready for them? I have to say that Steve and Kenny, they were ready, right? Like Laura mentioned, they did take the Passive House builder training. They did familiarize themselves with the materials. This was mostly new to them. They just build nice big houses out in the country in New Jersey, right? So this was new to them. They really jumped in and did it, and that was a big relief because it could have been a real problem, but it was not a problem at all. And if they had any questions, they reached out to us. They reached out to the team. I mentioned the shop drawings. They looked hard at the shop drawings. They had questions. They wanted to really understand what were they responsible for, and they did it. They made it happen.
And just a quick. Go ahead.
I just wanted to add real quick that I think what's left out of this a little bit is that our model is not in a silo. On all of our projects, we require a certain level of engagement. So we're talking about biweekly meetings for months and months. So what happens is as the model's evolving, they're seeing it every couple of weeks in real time. So they're very familiar with this thing before they even get the review set. And that's a pretty big deal. And they have the opportunity. We always also ask them to invite in their plumber and their electrician and to get a chance to chime in. So the model ends up reflecting really not just what Bryan and Ilka and I want to do and the architect wants to do, but really like what the team, can do. So that's a huge part, I think, to this.
And I've heard them called different things: leaders, jumpers, floppy bits, various names. And basically what you're doing is you're tying one scope to another and usually bridging a gap.
Yeah, and sequencing is both when you're designing in Passive House. I mean, when I took the builder training in addition to the consultant training, what I learned in the builder training is the importance of sequencing, which helps to inform me as a designer on how to think through a detail, what has to come first, and can you simplify it because of that sequencing. But there are always some in Passive House, some sequencings that are atypical of traditional construction. And that's where you need to bring people's attention that this might be a little different, but you're going to have to put this floppy bit over here before this arrives, or you're going to really regret it. So yeah.
Well, great lessons learned. And I'm going to thank this entire team for working with such a great builder to begin with and leveling them up, because they're not far from me. So now I'm excited to meet this crew. So I appreciate your hard work in working together to level up. And what a great project. The differences between the two buildings and how you really addressed all of the different sequencing issues between both was pretty cool. We have a question next from Dina.
Diana, hi.
Hi, Diana, Dina.
Hi, everybody. Thank you again. This is an amazing presentation. And I worked as a designer in Europe, and this is one of the best models I've seen, kind of showing really well for a contractor. I think they could not go wrong with having such a detailed model and such brilliant visualizations for what goes on. My question was about number of airtightness tests, blower door tests that are typically being done for a project like this.
Ilka?
Yeah, I can take that. So typically what we do is I mean, enough of the air sealing has to be done before you can even do a test, right? So sometimes we actually have done it before even the windows were installed, but then you have to cover it with membrane and tape it off. But basically what you want to do is definitely do a blower door test before the walls are closed up. Typically we do one before. It depends. I mean, it depends on the sequencing, right? But sometimes you're able to do a test to just kind of check the assemblies before the penetrations. That is very helpful, because then you can just make sure your panels and everything is airtight and they're all connected airtight. Then you can do your penetrations. You do another blower door test, definitely before you close up the walls. If you pass that one, you're safe to close it up, which we just did on this project. And then you definitely need your final blower door test. So we typically do 3. And that's, I guess what I was saying, I think what's really important is that once you have the blower door on site, and some people actually have one, so they can just kind of work with it while they go. But once you have the blower door on site, it's a really, really good time to actually fix all the leakage points, because otherwise you have to have someone come back and do another blower door test.
I just want to say in terms of our, oh, sorry, Steve.
No, you go ahead.
Okay. When we were doing the blower door test, one of the first rounds, we weren't making our number. It was important that we started sleuthing, and some of the things were just that certain things hadn't been closed off. Like in the sump pump, there was a pipe, right? And that pipe is that big. And that was a big air leak. So we had to seal that off and, and look and make sure that, because this is a big house, there's lots of things. So just finding little funky things like that, and making sure that you're actually testing the envelope and not a pipe opening to your sump pump.
On this project, I was really pretty happy that it's been different for other projects we've done, but on this project, considering how many like corners could have burned us, we did the first blower door test. We weren't terribly off, but like Laura said, there were some things that just need to be corrected. But then I think there was a couple days of Brian's team kind of sleuthing and taping and going around and finding some more things with the blower door equipment on site. Couple days, and then we came back in and we were all there for the next next one. So I felt great about that happening. Like blower door test, find some weak areas, a couple days, even a week, if it were, to kind of correct those things, and then to land a blower door test with some room on a building like this, I was like success. I felt really good about it. So
I was just throwing into the chat, Steve, that with great budgets and resources come even greater responsibilities, right? You had this amazing opportunity, and yet size was like, it's almost shocking, to have this much room for 2 people, maybe not in the area you're building it. It was probably very common there. But when we look across some of the sustainable projects that are, driving carbon down and driving size down, this project did a great job of addressing those materials, addressing the systems, and really educating the workforce. So thanks for taking your responsibilities seriously as a team. I think we have one more question that I'm going to read because it came in by direct message from Bryan B. Poppy, maybe. He said, the leaders on the walls appeared in the photo to be at the top of the wall and would then be applied to the bottom in the next section going up. But that means the leaders are not applied shingle fashion, in quotes. Why is this not a concern for moisture intrusion?
So those particular leaders they're on interior. And so the mento is to the exterior in the shingle fashion. And that's acting as your WRB. The Intello leaders are to sort of snake behind the floor system and other scopes. And then they get buried by insulation as well as that final WRB inside.
Amazing. I was going to guess that, but I'm glad you made that clear. So thank you, Bryan. Thanks for bringing the expertise today, everyone. Thanks to all for joining us. And Sean, thanks for throwing me out there with the Spider-Man quote. I didn't even know I was doing that. But I think we can then do a Toy Story and we can say it takes a team, right? Or is that Monsters, Inc.? I think it's Monsters, Inc. It takes a team. So thanks, Paul, Ilka, Laura, Bryan, and Steve. And by default, everyone else who couldn't join us today, who was on your team, Chris Sarek and others. And come back and join us again. We can't learn enough about this kind of team building, this kind of project. So, and thanks to everyone for joining us today. Have a great rest of your week, everyone.